All right. Welcome, guys, to today's workshop, Arduino workshop for lab. How are you guys doing today? Pretty good?
Yeah.
All right. Let's start off with first, how many people here know how to use an Arduino? Anyone else?
Haven't heard.
How many has used an Arduino before? All right, so let's first talk about what is an Arduino. So here is actually my little box of Arduinos that I can use every now and then. So an Arduino is basically a small little controller. It's like this. These are some types of controls that we have. I'll do them here. And what they do is basically control sensors and motors. They are somewhat like a computer, but they're not a computer per se. They cannot actually properly do processing the data as much as your computer can, because your computer is a microprocessor. Arduinos are microcontrollers. They're better suited for gathering information from sensors outside of them, and also outputting data to other things like LCDs and other things. So most Arduinos are open source. That means that many other companies can take their design, the original design, and still sell them. And they're based on the C and C++ languages. So those who know C and C++ should be able to pretty much easily grasp how to program these things. But also they're pretty simple to start off with in the first place. But it's also kind of really fun. So hopefully we'll be more interactive and intuitive when you guys learn how to use this. Okay. So I'm gonna start off with some projects that we've done with Arduinos. So one of them being our actual Hyperloop pod. This one right here, you see there's two Arduinos that we mainly use. There's one on the actual pod itself and one on the small controller on the side. So the pod controls basically all the temperature sensor probe, and as well as the motors themselves. We did a temperature sensor probe. And as well, the controller transmits the data from the joysticks to the pod so you can move left and right. Another one is our RC car, or our line following car from last semester. Those who are here for that workshop, you guys know, you've seen this before. You've seen what it does is basically it follows a black line on a white track. So like follow that line, like it'll go around the track. A few other projects that I've done, I can show you guys here, is stuff like our. I know I'm gonna we start off with say an intro. First, like a pretty basic one would be something like, something like this, which is basically if you press the button, a light will turn on. Press the button again, turn off. We'll go to a different state. So you'll see if I press the button again, the light turns off. And then you see the red LEDs also near the Arduino over there. If first initially turned on, back over here. And it's right there. Turn on first. Let's turn off later. Now this project was made for was actually for this right here, which is a lamp that I made, 3D printed. So I used some 3D printing, 3D modeling skills, 3D printing skills for this, as well as Arduino and some sort of construction to create this lamp that could basically switch colors, fade in, fade out, all that. Pretty cool lamp. And then, yeah. Yeah, then after this, you need to get a little step forward and make something like this for, you guys remember the Blinky Lunar 3 kits? They're lined of the LED chasers. You can use an Arduino to basically control these LEDs instead. And you can get a little waveform over there. This one right here, I think it's actually synced to music, but I don't know if it's not needed. Okay. Kind of, but I basically use a script using Java on the computer to send the data over to my Arduino, and then output it to the Arduino's like output pin. And this was used for something that my personal project over here. I called it the ray table. But the whole thing is controlled by a single Arduino that is sitting right down there, over there. So that controls all the lights, everything. Yeah. I think you guys might have seen, if you guys were here for when we first started off, the workshops would be the macro board. If you guys remember those ones, it's like basically a little shortcut, like small keyboard. You can program shortcuts into it. It'll output keyboard commands for the press of a button. That one's a small little Arduino as well. And last but not least, I'm going to show you some motor controlling. So a stepper motor. The practice that I did using this, don't follow that, the wiring in this, because it causes smoke, because there's something that you shouldn't be doing with this. I'll talk about later. But it does control the stepper motor, which was used for our JPL competition to shoot ping pong balls 5 meters away. So the press of a button.
Wait, the balls are still the same 5 meters. Ours also 5 meters.
Yeah, about that. Same size, yeah. So when I press the button, it would move the servo motor by 60 degrees, and it'll launch the ball by itself. So it's a lot of things you can do with an Arduino. That's basically the plan of this. You start off small, and you can do something complicated. It depends on your imagination kind of. Okay. All right. So the standard Arduino, this schematic is for the Arduino Uno. So this is what most people see when you think of Arduino. It's this one right here. All right. See, it's the pins right there, pretty similar. So there's 14 pins on that one. So there's 14 digital pins, which means that if you know what digital means, it's either a 0 or a 1. So 0 means 0 volts, so 0 output, and 1 means 5 volts. 0 means off, 1 means on. It's how you use binary, and this will be really important for when we do later on. It also uses, so you mostly want to use pins 2 to 13. If you look on the side, pins 2 to 13 are GPIO 2 to 13. 0 and 1 are communication pin. Don't think about that too much right now. We're not going to go over serial communication yet, but you don't want to use those pins when using your Arduino for now. It might interfere with programming it or something like that. We also have 6 analog pins, which are on the left bottom side. So pins 14 through 19, or A0 through A6, or A5. Those ones over there, they can read analog input, which means it's not just a 0 or a 1, but it can be in between that. So by that I mean, like, so you know how 5 volts is what a 1 is in the digital logic space? 5 volts here is 1023. The reason why it's 1023 is because it's to the power of 8. Yeah, so 0 to 1023. So is that 2 to the power 8?
Yeah, that was 24.
Yeah, so that's the amount of, like, bytes. You have 8 bytes of data. That's what it is. If you guys know what communication, computer stuff, that's what that is. But how we're going to use it, well, nobody will use it today, but it'll be able to read different voltage levels from 0 to 5 volts. So many sensors out there for many different, like, let's say you want to turn the volume knob down or something, right? It'll be a bunch of resistors. So what that means is it'll lower the voltage a little bit to kind of output a different signal, right? So instead of giving you either full or nothing, they'll give you something in between, saying you're not exactly at the full level, but you're not exactly at the middle level, you know? But using analog, you can kind of get that same middle level signal. Does that make sense or no? Does everyone understand? Okay. But you can also use the analog pins as a digital pin as well. So you can output 0s and 1s, or you can also read 0s and 1s. Are we good? Like, let me know if you're just like, yo, just don't understand anything, okay? So I can, like, explain better. Okay. So let's just go back for a second. So if you look at the side of the digital pins, you'll see some of them have a little squiggly line next to them. Like pin 6 over there, a little squiggle next to it. Pin 3, little squiggle next to it. You guys see that?
Yeah.
So that means it's a PWM signal or pin, which means it can actually output a fake analog signal. So how this is done is using what's called pulse width modulation, or PWM. So what will happen is the pin will write either full or nothing, but really fast. And if it isn't at a certain frequency, it can kind of fake a certain voltage level. So if let's say the pin is high or on or 5 volts for half the time, and then the pin is off for half the time, right? With for like one cycle of say for 160 hertz. So like for say 1 second, right? For 1 second of the time, it's on for half a second, it's off for half a second, right? That means that the duty cycle or the time that the pin is high for its total period of time is 50%, which is half the voltage. So it will basically fake half the voltage. So you see on the middle one right there, the middle signal wave is showing you that the pin is on for 50% of the time, it's off for 50% of the time. So the voltage level it'll output is basically 50%. Right? So you can use this to turn like LEDs at half brightness. Or you can use this to output a signal we're going to use for the buzzer today. So we're going to make a little mini piano like we did for a soldering workshop. But instead of desoldering it, we're going to actually program it. So we'll use this exact kind of thing. We'll give it different frequencies so it can output different sounds for us, different pitches. Okay. So to do this, you guys need some basic circuit knowledge, which is Ohm's law. Hey, most of you guys here are electrical engineers, I'm assuming. Yeah. But some of us also need to like so. Ohm's law is V equals IR, which means voltage equals to current times resistance. This is kind of very important in all of electronics. This will help you figure out exactly like what your power requirements are, if making sure that your components aren't overvolted or just not enough current going through them, so they're not supplying enough. So one thing to note is that current is kind of constant in a series circuit, so which means that you see those first two resistors, R1 and R2, since they're right after each other, they lead into each other. That's called a series circuit. So in those two resistors, the current level would be the same. Okay. In R3 and R4, those two resistors are parallel. So they don't lead into each other. They're giving two different paths for the current to flow. So in those two, the voltage can stay the same. It's called Kirchhoff's like voltage and current laws. We're not gonna go over them in depth for this one. That's more for circuit construction. But something to note, if you guys want to know more about it, when you guys do other circuits, this is like it goes here. And also this power is equal to voltage times current. So when you look at your power supply volt, like how many watts you have of your power supply. So in case just so you know, you have enough power to supply whatever you're doing. So we're gonna go over some current requirements for certain components soon when you do the lab. So yeah. So always make sure your power requirements do match the device you use. The reason for this is something I learned when I was building my own circuits for motors. For that motor, I told you don't match the wiring diagram. So in that one, for this Arduino right here, you can input up to about 12 volts, or and with about I think the pin in this or the V in pin or whatever voltage that's coming in, it can output the same voltage. It can only output about 800 milliamps of current. So amps is the unit for current. So about 800 milliamps is 0.8 amps of current. All right. The motor requires 4 amps to run. Okay. And this V in pin can only supply 0.8. So if you don't match what you're doing, so I didn't match my motor's requirement with my pin required in output. This started smoking because we were really hot and it started smoking. Luckily, I saved it before it died. But always make sure and you look at your power requirements and kind of match them. So if you guys don't know, just look online for your components. Make sure you're getting the right proper requirements for them. All right. So let's solve some programming. Does everyone here have their computer with them? Okay, cool. So I want you guys to open up the Arduino IDE so we can just look over the IDE itself. So okay. You guys have the IDE 2.0 or 1.8 below? 2.0 has like the full dark mode and IntelliSense and everything. 1.8? 2.2? So anything higher than 2 is I'm not saying. All right. But they're also still very similar, either or. But let's go over some functions, some basic functions. When you first open up the IDE, when you open like a new sketch, you will see something like a void setup and a void loop. So here is mine. When I first open up mine, you have the void setup on the very front. Oh, yeah. Okay, I can let's see. Okay. You wanna help?
Okay, yeah.
Okay. Everyone else has ID, right? Okay. So let's talk about void setup and void loop, right? Your void setup function is basically when the Arduino first turns on, it will run that code once to set up anything set up any first functions it must run, right? Let's say you want when you first turn your Arduino on, you want it to blink an LED once, say, hey, I'm ready. Or print out a statement like, hey, I'm ready to go. You do that in your void setup. Your void loop is basically it's an infinite loop that the Arduino will run. So I'll be constantly going through that loop, running that same code, just looking for any sensitive data or outputting any data. That's your main, basically your main function is in your void loop. All right. Are you all following along? Okay. Yeah. So these two functions are also very important in your code because the Arduinos themselves look for those two functions. If they're not there, your Arduino might not run if the code that you want to run. So always make sure you have those two functions. This is a bit of C and C++ are similar. C++ is this like object oriented, right? So I'd say it's more C, but C++ also I believe so. But you'll see like a lot of like similarities with like C and Arduino happens. Yeah. So let's first talk about defining variables. All right. So when we have defining variables, or what variables are basically stuff in data allocated in your memory with like sort of name you want to put it that you can like store for later use kind of thing. So you can also there's like variables that's like stuff you want to say your inputting data. And you want to save that data temporarily for use in some function. What we're going to do, you can make a variable for that, still store it. You can also make constants, which basically are like you have one variable and it doesn't vary. You have one variable, right? That you will use for everything else, but it will not change. It'll stay constant, but you want to update that one variable in case you need to change something else. But you don't want to ever change in the code itself. You're gonna hard code it in. You're gonna change it yourself. That's when you use constants because you can have tons of lines of code with that same constant, right? You don't want to keep writing the same number or the same letter or whatever it is that you're running every single time, every single instance. So having that in one place where you can just change that reference point and everything else will change automatically is a lot more useful. So you can define variables using a simple syntax of using, first of all, your data type, then using the variable name itself, and then the value you want to use it with the equal sign. The equal sign here is called the assign operator. So you assign a variable a data point, whatever it is. So a lot of data types over here. We have int for integer, double for decimals, bool for boolean, string for string of letters, and char for characters, or char for single characters. You can define characters with a single quotation mark on both sides, strings for double quotation mark on both sides. There's also other data types out there. There's like long, short. It's like it all depends on your use. But for our case, for our introductory case, we're just going to use these 5.
For Python, I know you can use quotation marks for either languages or sections that applicable to.
No. Python is no. In my opinion, I like this a bit better. You're not in Python, you don't even define the actual data type sometimes,
Okay.
right?
Yeah.
it's just having the assignment there is just nicer to pass, in my opinion. But that's me preferring C over. But yeah. All right. Now, in order to make constants, it's the same exact syntax, just putting const in front of everything. So const will make it into a constant variable that you can.
When you're defining pins,
Mhm.
are there specific types of pins being defined as full spin and group pin, or are those the names you're giving?
So those are the names I'm giving them. So I'll talk about the hash rate define method for those later. Right now, I'm going to talk about the name how you usually use for most variables. For pin definitions, I tend to use the hashtag define syntax, which basically all I gotta do is the hashtag define the variable name and the pin you're gonna use.
Oh, the numbers and pins.
Yeah.
Okay, got it.
And that's all you gotta do. So in my opinion, it kind of makes things a bit easier to define all your pins. So up top is the hashtag define. It's a different color in Arduino 2.0, right? And then using your actual variable that you do use, you intend to use in your code that's not a pin. You can use the normal, in something or something.
What is the other constant? Like, is it always like constant something high?
No. Wait. So just delete the const in front of it, then you get the normal variable. Like
That's the difference. Cannot change. Like the shit sign for that.
talk about like constants versus variable, right?
Oh.
So sorry, yeah. So I const in my code because this is actually just to drive the stepper motor. I need to see constant. But for normal variable declarations and initialization, you just use the data type first. You do the constant. The const is there for only for constant. Okay. All right. Comments. Comments are, I'd say, some important, in your code. You can use two. I've never known whether it's backslash or forward slash, but 2 slashes for line comments or single line comments. You can use a slash with an asterisk and end it with an asterisk and a slash to make a block comment. So you can see a block comment right here takes 3 lines and then a single line comment. Right. So they're pretty useful to make sure you can read your code in case you don't. There's been times where I do like 5 hours of coding in one night. The next day I'm like, okay, what do I do? I can't read my code. Or I can, but it'll just take me a while to read it again. So comments are very, very effective in saving time for you and for other people who need to read your code as well. Okay. So let's start going to actual Arduino functions themselves. All right. One of the first things you'll see is pin mode. Pin mode is very key, and you're going to use it in your setup function most of the time, or almost all the time, actually. So what it does is it sets your pin as either an input or an output. You want to put in a setup function so that you can set up all your pins to be exactly how you need them to be. Whether it be inputs gathering data or outputs to send out data. If you don't do this, it'll probably be I think the default pin mode is output. So if you want to read data in, but you don't use pin mode, you can't read data in. All right. So pin mode's like syntax is just pin mode parenthesis. You put your pin name or your pin number, comma, whether it's an input pull-up, or output. Now input and input pull-ups are they both are inputs. But what input pull-up does is it sets its default value to 5 or 1 or 5 volts.
Oh, I see.
So what happens is sometimes you might want to, instead of reading in like 5 volts for an on, you want to read a 0 volt for on. Right? There are components out there, such as a Hall sensor. A Hall sensor senses so magnet is present, right? But the Hall sensor outputs a low or a 0 volts whenever there's a magnet present. Otherwise, it's a high or 1 or 5 volts. If you use normal input, that means it's going to read for a low, but it's always going to get a high until there's a magnet present. With the input pull up, it'll always be a high, and it'll always read for a low. So the Hall sensor, that's always a high unless there's a magnetism you can easily detect whether it might there or not. Make sense? Okay. All right, another two functions that are pretty key for Arduinos in general will be the digital write and the analog write functions. So these can only work if your pin mode is first set to an output, because you're gonna write out to the pins. So digital write is your normal write of writing out a 0 if there's nothing there, or a 1 for 5 volts. So 0 will output 0 volts, a high or 1 will output 5 volts. So when you use this, you use digital write, and then you put your pin name or pin number, and you put comma with either a capital high or capital low. That will be how you use digital write. For analog write, so what that one does, same thing as digital write, but is an output the fake analog signal. So this only works for PWM pins. So don't little signal mark on them. So it has a maximum value of 255. So 0 is 0 or off, and then 255 is your fully on. And then you can put a range of values between these two values. So if you want to go half brightness or half the motor speed, you put 127. So that is half of, that's not fully half of 125, 155 is like, doesn't matter. You can use integers in this case. Anyone follow along? Okay. So the next one is digital read and analog read. So these can only work if your pins are set to pin mode input. So digital read again only reads in zeros or ones. So 0 for if it's a low, or 1 for if it's high. So if 0 volts are fed in, it's going to be 0. If 5 volts are fed in, it's going to be high. All right. Analog read only works for the analog pins, so A0 through A5. And it'll read a value from 0 to 1023. So yeah, so 0 being 0 and 1023 being maximum voltage. And you can always use ratios to like figure out exactly what voltage you're getting out for inputting. All right. Another function that's kind of cool is the map function. We're not going to use it today, but we can if you want to get something to go with it. But it basically maps a value from one set, from one say coordinate system to another coordinate system. So let's say you're inputting data from your analog pin, right? It's 0 to 1023. But you want to write it out directly to your PWM pin, 0 to 1025 or 0 to 255. So you can use map right there to basically convert your analog pin reading to your PWM output. You can also use it for like converting two different types of like, let's say you're reading a letter 0 to 1023 kind of thing, or say you only want to read a certain like range of values from your analog pin. Let's say you only want to read the values from 10 to 30. But between that range, you want the output to be something completely like 30 through 70 or something. You can do that with the map function. It's very useful for a lot of things like that. Okay, let's talk about some if-else statements real quick. Does everyone know how if you want to decide for something, right? You want to basically do, if I do this, then this should happen, right? If I don't do this, then something else will happen, right? That's what it is. So you can use this to, let's say, do some logic, or if you want to press a button, if there's a button pressed, right? Maybe increment a variable by 1. If there's something there, turn LED off. So that's your if-else statements. You can use conditional operators like those. I left one out, which is the equal sign. I'll put in after this. But you basically have your greater than equal to, less than equal to. Your exclamation point is your not operator, so we'll kind of invert whatever your statement is. And then you have your equal operator. So instead of using one equal sign, you'll use 2. because one equal sign means you're assigning a value to a variable, and two equal signs is you're comparing the two values, whether they're equal or not. And your and operator is if you kind of group two statements to see if both of these are true, then it'll output a true value. And your single line or both your vertical line operators, that's your or operator. So if this or that is true, then output true. So if statements only work for if the statement is true, if the overall statement is true. If it's not true, it'll go to else statement or an else if statement. So you can use this to kind of like figure out when to do what you want to do. There's also a different type of statements called the switch in case statements. We're not gonna use those for today, but they're a bit more advanced in a way. But yeah. Are you following along? Okay. So this will lead into our for loops. So the for loop is basically a loop. So that will basically that's an iterator. So if as long as a certain condition is met, being if say a number I is less than another number, then iterate this or go through this loop and add one to that number. So kind of run for a certain amount of times. So this is for my servo motor code again. So basically the step for the step count up there, do like turn this pin off and on and keep this pin like turning off and on until the whole motor runs full revolution. So that's your for loop. This is based off of the while loop, which is while a certain statement is true, do this set of code. Okay. Does this make sense? Okay. All right. All right. The void. Void is used for creating your own functions that have no returns at all. That means is you can use this to create a set of statements and functions that will execute the statements and then continue with your code, whatever it's doing. Those who know some programming also might know how to do return statements, like those functions that use like say int to return an integer. So we're not going to return anything. It's gonna be a void. So it'll return nothing. It'll just run the code, and then it'll continue running. So this is good for grouping your code segments into bite-sized pieces in a way. So you can read your code better, and then once it's not a whole mess of like thousands of code, and you don't know where it's going. Right? You can name your functions as something important to you. You can have like 10,000 lines of code, but with like mini functions in it, so you can find that function real quickly and then change it. You can also call that function multiple times as well. So like you copy and paste the same code again and again.
When you say it doesn't return a value, returns a value for what? Yeah.
There's no return at all. So do you know how to return statements work or no?
No.
Okay, so returns. So there's another way of writing a function. Let's say you use a data type instead of void. You say a string, right? If I wrote string try that, right? That means this function is expected to return a string data type. So at the end of this whole, when it finishes running the code, it should say return and a variable or a string. So the code will expect to see a string afterwards. So what void does is it doesn't expect anything. Yeah, so the code will run and it will continue on. Huh?
Just execute.
Yeah, just execute the things that I else. Okay, we're all good? Are we too fast or is it good? All right. Let's go on to actually seeing what we can do with it. Okay. So I'll give you guys an Arduino, a breadboard, some wires, a buzzer, and a button, and we'll see what we can do. All right. So our Arduinos are going to be these right here. Are you all in the Hyperloop Discord, by the way? So I'll teach you guys how to. So for these ones, there's a special step you gotta do to be able to like upload to these boards. So I'll put the link in there. We'll run through it with all right.
Thank you. What do you think?
Are we gonna?
I mean, I'm not sure actually.
I think sure.
This is the one I got. No, like, so you have to go with. So that's good. Now I have to get. Yeah. Look, Don. We'll see. Yeah. I'm going to go get one now. Sorry. Like, look at our chance, you know, not giving me discounts.
Well, I'm not gonna stay for too long. I'm being supportive.
Thank you.
Oh, well, yeah, you can code too. What else? It's fun because
Please give me the.
Oh, right. Yash, you started this?
Yeah, I first today.
Oh.
Yes, I know, it's not so fast. Don't tell me anything.
Yeah, I roast you.
No, don't roast.
What do you do?
The letter is like this. Like when we should just it was like so close.
I haven't done.
For like 3 hours, series,
Yeah.
Go here and you drop it too.
I'll take a this. It's a little.
Yeah. It's funny.
Well, the code.
They're gonna get buzzers, they're gonna get.
Oh, yeah.
Wait, what?
Yeah.
So how about asymptomatic? And you know how about scared?
Yeah.
So sorry, it's out of the way. Like I didn't register that.
You know some bars?
You know, yeah. Now they're bar. Like, you can each. Whether you would be.
Five, I think it's 5 bars each.
They're gonna be more.
Yeah, you bar. These are the only use. If they need more, my personal one as well, but like.
Just jump through line.
No way.
Jump through line. Oh.
Oh, good job.
Oh.
Hey.
Shut up. Good no, bro.
I'm so nice to you. Thank you.
Wow.
What are all these holes? We're not holes.
Oh, this is the kind of everything we just find. Like, we just like, when you crack, he's like goes 1K or
I'm gonna do it.
I think it's red words.
Yeah. Oh, we use nice.
Yeah, it's very brownie.
Let's deviate this time. We're so sorry. It's okay.
No, you gave me. Because you would,
Yeah.
Wilson color. Yeah.
You guys can help.
Alright, now I'll tell you both. I think
I don't know.
This ratio,
Yeah.
Yeah.
such high stuff.
Yes.
Alright, so. mm, yes, alright, let me quickly.
I'll probably have such nice chairs.
No, we don't.
No, like, bro,
Okay.
compared to high school. I'm doing so fast. That's so tough.
Dude, yeah, like, they're not just 1960s.
I know, you know, one of like tables in the back.
Yeah. I have those. I
Okay.
have my age.
So, those who have those who have these ones, listen carefully. On the Hyperloop Discord, I'm going to be putting in the announcement tab a link.
What the?
Alright. Those who don't have a link need to hit the HTML.
Oh dear. Oh dear. This is scary.
Don't worry about that code. I'm just gonna put it for now. Right.
Is it gonna give me a virus?
I'll add you to it. Give me your. Add you to it. Okay. Here's your link.
Yeah, it's post high school to create us, right? No.
Sure. Okay. So what we're gonna do for those over there, you're gonna copy the link. So in your Arduino IDE, right?
Yeah.
We're gonna go to File.
File.
We'll go to Preferences, and then under here where it should be additional board URL. All right. You can just click this big right here so you can like kind of open it up. Right. Paste the link that I sent into there, and then press OK.
Oh.
All right. Here.
So smart.
Wow.
And then you click OK, right?
Yeah, then click OK. All right.
Okay.
So and then if we all did the step, right?
Yeah. Just a nice simulation.
Because he has to do. That was like a while. The second one was.
Because when you think 1958, most of us read.
All right. All good?
Yeah.
All right. So what we can do now is okay, facilitate first. Okay. Yep.
I keep having an issue where I think Windows is like forcibly turning on Windows 8. So just like now it's fine. Additional boards, click the button. And then, you know, then how it's all together.
Well, you should do 16 streams.
And you could write this on the layout. I did like coffee. Yeah, that's how I did it.
What is it?
Yeah, they came here. Yeah. Did they go? Oh.
I don't think.
It'd be better if you,
The city codes, the time of the year.
you know, if you want me, I can like put the blue. Or the blue them.
Can you? I don't know how to do that.
I can do that.
Sure. It might be.
Okay.
Sometimes.
All right. You're leaving. All right. Everybody else, can you plug in your Arduinos to your computer?
Wait, how?
I give you guys. I give you guys. You.
Bro.
So, segregation.
Yeah.
So rude, so rude.
All right. Hey. I'm
Space danger.
burn the Google really quick.
What?
Take it from the existing board.
Oh, that is so sick.
It's or this. Oh, this is mine. This is mine. Yeah, it's mine. But this one isn't. Okay. All right.
We're just not know how to publish. Hold on, what the heck? I swear.
So. All right.
Yeah. We gave it life.
Is that actually one of the ones that have observing?
Yeah.
Okay.
Is there not working? Wasn't working?
I was just wondering.
So the urge to just like.
But these are actually a different.
Oh, good. Alright, good.
Oh.
Yeah.
Wow.
Yeah.
So.
Wait, is this one like how do you?
Okay.
What is our?
Yeah, it's
Like.
And I think so. Is there like other consistent? Maybe I'm not just that one because there are these
Forget
I think. How to find it. That's why I don't.
I have ideas, like I wanted to do sure Python server and then just like if I want to for 1 minute, still it's like so I wanted to see like do that like oh it doesn't seem too hard.
Yeah, because all you need to do is like do that script funding thing.
Yeah.
Those the operations here.
Yeah.
Down there.
Right, and then depending on what that gets.
Have you ever got to
Yeah,
the
so it's over. Scripting Java.
What's idiot? So.
No, I think somewhere school, right?
Yeah, it's some school. It was no B. That's like.
I think civics.
Uh-huh.
It's just it's scary.
Oh,
Not scary.
what?
You don't know.
What?
It's not around the
Yeah, like anyway.
Yeah.
Let's look for the.
I would recommend project the table.
Deep sense of regular.
Yeah. Right. It can be.
Because Dunbar High School does great. Look at this. Oh, that's a typical way to.
So the passes for this looks like
Then HP house 18 physics one versus liquid gravity.
High school is 8.
You're gonna just out.
Oh.
I know, if I got 480%, I could have stayed in. If you get 480, you'll probably your grade by 2 hours. But most people, most of it.
Alright, alright. All plugged in, all flashing, all blinking, yeah, okay.
Yeah.
So,
If you're charged, maybe
alright,
was. I would guess I, is it not seeing? But, no, she had the computer. Or it just, her computer can't charge, so she's gonna have to not be able to use the computer. Nothing about it.
Yeah.
I'm in the Hyperloop server. Okay.
You could,
Oh, no,
also use computers. Yeah, but you have to,
No.
install it.
No, you're gonna have.
Like transcript.
Okay.
No.
Alright,
I mean, can you install things for someone? Or, yeah.
you guys plug it in.
You already talked to like this one. If you have a 3.8, you're like, right, you can do that. Look at this,
No, this is dead. Cool. Alright,
Wait.
so when you plug in your board, those who have any of the Arduino player, plug in your board, right? Click up here, up here, and then click on the board. If it's unidentified like this, what did you guys say? You have math. You have math. Okay. Arduino? Don't use that. No. So select on the board from here, and type in at mega. Oops, I spelled it wrong. So this is from up here. Click this, select board, other board import, and then type in at mega, and you should be this one, right? I don't you just have one of them.
We do that only to show unidentified.
Or if it's something else, because the board should say is gonna be this right here. When it's up there, it should say add mega 328 TV.
How do you spell that?
ATMEGA.
Oh.
My.
What the?
Oh, let me see how to do it. Wait, actually.
Bro, I probably didn't support.
Yeah.
Is yours saying?
Yeah, that's what mine said. And then the error message. Well, we know. I think ours means.
All right. Are we all at the step where you can see the abnormal up there?
Yeah. Yes, sir.
Okay. So let's first do a simple program, okay? We're not doing any circuitry yet. We're going to use basically what is the LED that's built into your Arduino over here, okay? This is called the blink, test basically. We're gonna write up here. Let me make this into a. Okay. All right. Let's go up here. I can't see this far. Okay. So let's first talk about. Do you guys remember how do you define variables? If I were to ask someone, tell me if I want to define the LED pin as pin 13. Does anyone know how to do that? Okay. Yeah, I think that you can also do the same. Yeah. So there's two ways. Remember, for pins, you can do constant as well, or have to define. For us, we'll do hash to define. Okay. So hashtag define. So let's call it LED pin as pin 13. All right. The reason why I'm doing pin 13 here is most Arduinos have their default pin attached to pin 13. If we actually look online real quickly, let me go and search up the as well. If you look at the documentation, so you can just search up like your board, and then it like a pinout. Let's say you can see its current pinout, how things are. So here you see 13 here. You're looking over there. Also within 13. Okay. So let's do that. I'll bring it back. Okay. All right. 13. Okay. Let's do a variable for time, a time delay. All right. How would you define that for a time delay? This is a number, yeah, but let's say I want to make another variable for the delay in the so when it blinks on
Oh, I can see.
you can do int constant, yeah, constant int. So we'll do that, okay? So const int, let's call it timer or time. Time with two e's. So I think time might be an actual variable. Okay. All right, equal to or assigned to. Let's do 1 second. So in Arduino, you have a function called delay. So that's the delay or from running the next line, right? It runs in milliseconds and microseconds. So 1000 is 1000 milliseconds, which will be 1 second. All right. Okay. So we have that. Let's define our pin mode, right? We want our pin to be an output. How do we do that? Yeah, dude, you can type an output. What's our function? What's our syntax? We're not writing anything right now. Huh? Analog read? No. No, we're not writing anything yet. We just want to set the pin as an input pin or an output pin. So we're gonna write out to it.
Like see it.
Not see it. It's not see into like the console here.
Pin mode and then it's
No.
Pin mode, LED pin, and output.
There we go. Right. So in your setup function, because this is our setup stuff. So pin mode. Oops, I can't spell. I also can't see. Pin mode. Did I spell it right?
Yeah.
Pin mode.
You can look it.
Pin mode. We're gonna type in LED pin as like use caps lock for output. All right, and make sure you end most of these statements with a semicolon. Right. Aside from the very first one, which has to define, that one doesn't need a semicolon. But everything else, make sure it's semicolon, unless you're defining functions. You know what I mean? I don't. Okay, semicolons define the end of a statement. All right, go to the next line. Because in C++ and Java, you could write in a single line. All your code in a single line. As long as as long as you put semicolons, it can read all of that. It's terrible, but you can do it. Okay, so don't do it because you can't read it. So, okay. And that one, all right, let's go to our loop function right here, okay? Now, I want the LED to output it high, right? I want to turn it on first. Then I want to wait and turn it off, and then wait again. So that first statement. I want to turn it on. How do I turn it on? We're not reading anything. Digital write.
Yeah.
So we're now just writing out to the pin.
Is it like a higher low?
Yeah.
So we're gonna do digital write. Right? I spell it right? Yeah. Digital write and then LED pin. LED pin. Type in high with capital H-I-G-H. No, oops. H-I-G-H. Semicolon. All right. That will output your LED as a high. All right. Next one. I'm gonna put do it yourself. Do this one. Type in delay and put time with 2 E's. That way, it's gonna be our little variable that we made earlier, our constant variable that we made earlier. Okay. And then, all right, I want to turn it off now. How to turn it off? You have that entire statement.
Huh?
The
These are
entire
right.
statement. There we go. Okay, so digital right, LED pin, low, and then I'm gonna do delay again for the amount of time that I want to put as time. Oops. Okay. Right. So we basically define our pin first. We define our constant that we're going to be changing later on. I'll show you guys later. Then just turn the LED on and turn it off. All right. Very simple. Are we all here? All right. Are we all here? Yeah. Okay. Now we can go over here. So this check mark right here means to compile, or it'll first see if your code is even correct, your syntax is correct, or basically how you write it, if you can read it, right? And then if you press this one right here, it'll compile it first, and then it'll actually upload your code. Upload your code to your Arduino. So just click it once, and you'll see compiling, uploading, upload error. Could not find my communication port. Does everyone have an error? Okay, if you have an error, just click up here. Make sure you click on this. So make sure your communication port is correct. So whatever communication port you have. What is it on? Yeah, the admiral has on 9. So now then press the run button.
This one?
No, only you can not declare.
I will not change it before.
So case matters, remember guys.
No, so.
Okay, so let's run it again.
I'll give you something.
And it should run. All right, uploaded, and you should see your LED blinking, right on the very bottom here.
Yeah.
Yeah,
Yeah.
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 Y'all have blinking.
Like that.
All right. So thing is, before when I was like learning all the bootloaders for like Arduinos, they already had the blink function in it. So we'll make it really fast now, okay? So go over here to time. Yeah. Okay. So okay, we're gonna make it extremely fast. Maybe like I don't know, 10. Yeah, 10. All right. Not one. Let's do fast. Okay. Let's see. It might be too fast for it. So let's see. It's way too fast. It'll stay on.
Oh. 100.
Oh,
right? Is everyone just staying on?
yeah.
Bottom right?
Yeah, bottom line. Blinking?
For, oh yeah,
You
sorry.
change the code?
There's an error for it.
Error.
Double check it, use that some more for it. Or I compiled it with a thousand, now it's added, I can do that. Or somewhere. I mean, honestly, yeah, this is the board, I mean, yeah, I had this from the last time that they gave us, and I was kind of messing around, or I got the board.
Okay.
And then I chose this board, like, so just, so maybe it'll probably be this. I think. Do 100. Or should this, so, wrong, my name goes down.
Okay. I don't know, you need to press up and file, that's up. So.
I mean, that's correct, it's something that's. Or it's. Yeah, that's correct, it's just, like I said, I installed. So now it's not installed.
I mean, this is from your last time, or did you?
What, this is the one you just gave. Sorry.
Workshop is this? How do you know?
The non-running board. I mean, there's like.
One.
These are LED school.
Oh, same as this is
One that Barbara,
Wilson and Wilson and one. Wilson is just English all that.
why was it? You know, like, because I think I would be asking you. So that's the only.
So what was that? Well, basically, I gave some. This is not really an official Arduino in general. But it has an Arduino chip in it. I basically went to GitHub and found the proper to run the code, kind of translate it to this.
To this.
Yeah, that's pretty cool. Yeah, because it's different, whole different things. Yeah.
All right.
All right. Yes.
I think mine's uploaded.
Yeah, I don't think it's the place.
It's just no. You're showing that it's starting. I don't know.
That's
I have no idea. This computer was good to get it.
You the thing.
I didn't. I didn't.
Yeah. I guess it is.
I went away.
That's the good one.
And then you trying to find.
This one?
Edgar.
They went.
That's why.
Oh, I.
Pero me da miedo que
What?
always. Oh yeah,
How, okay, Pakistan is gonna.
Yeah, it doesn't matter if I
That's like.
just watch. You know, I think my favorite.
I don't have you on.
If you're not, no.
I'm gonna let it, I'm gonna clean, I'm gonna.
Oh.
Wait, see, lights,
The light.
so as this one or like the crystal? Oh, yeah, no?
Yeah.
Oh, I see, you don't do that.
And then, yeah, do you know this name?
I actually was smart enough that I did during the summer. Or at least kind of during the summer, I didn't get to work, or at least apparently someone just said, told me that it does wait for a long time, so I posted it for a long time. And then, or at least actually it's because, what is it? It's, I was talking to someone else, because it's. Alright.
Everybody.
So let's walk over.
What?
Never seen that.
Oh.
I'm so.
Yes. Oh, you know.
The prison. Yeah. I probably should have left that straight over to the movie. Think about it. Maybe I don't. I thought I was gonna be. Because I. Yeah. Fine. I'm gonna take this fried shit. What else I have? Yeah.
Yeah, some people have it. I'm gonna see what happens, okay?
Yeah.
Yeah. Have issue as well?
No, look,
Or
I
if
think.
you can run this or.
Give me a second, give me a second. Hey. Oh, I turned the camera off.
No, I know.
Okay. Okay. All right, what do I see? All right. I'm gonna run this one.
Oh, yeah. But the thing is that.
Unconfirmed. This is this one. All right. If it doesn't work, I'm gonna burn it again, okay?
Yeah.
All right. And the error.
It's compiling now.
Okay, and that, yeah, it's on forever now. Okay. I'm gonna go back to yours. Okay, what's your error? Oh. Yep, that's the error.
Oh.
Well, some people.
There's actually.
Only thing I could go wrong is sometimes UPS.
Let's say.
To the, yeah. Or or we had a tower, yeah, you had something on top, like, on top was just to give you more. I went to the second one.
Yeah, look at my.
We did a project where apparently it's like, you know how you mentioned there was like letters, you got letters, or there was a project where you got lights with letters. Yeah, it's like rows in the tree, yeah, so it's called the light. It's not like, yeah, we're like LEDs. And on the, we could print to make the letter E, it's like three, there's five of those, so you can make the letter E or I. Yeah.
Anyway, everyone's good? Everyone's good? Okay, so is yours working or no?
No.
I'll come back to you later. Okay,
Alright.
so
Yeah.
gotta keep the book before moving forward. Okay, so now we're here making a blink and blink down. All right.
Damn.
Alright.
Does yours work?
Oh, yes.
Oh, yeah.
I'm the one who made everything. Okay, so let's plug in a buzzer.
Oh, no.
There's
the other-
URL, like 3 times I put it, or, you know, it's only 1 time in the thing.
Okay. So on your breadboard, all right, your buzzer, your little tiny buzzer. Okay,
Yeah.
let me go to Zoom real quick. And turn the camera on. Okay, so your buzzer has a little plus icon on it. Yes,
Or, I mean.
on one of these. Okay, that's your positive lead. Okay, so on your breadboard, you're gonna put it in across the center like this. All right. So how these breadboards work, for those who don't know, so these rows are all pinned as one. Okay, like these 5 pins on this side are, let's see, across or one long lead. Same for these 5 on the other side, and these 2 are just all the way down. Power lead. Okay. So what I'm gonna do is we're gonna go. We're gonna get a wire. So we're gonna plug the positive lead into pin. Let's see. Let's do pin 8. So on your actual board, you'll see it as so pin 13 is PV5, okay? And pin 13 on your board.
Oh.
So it's not actually labeled as 13, it's labeled as PV, right? You have PV5 to say, you have PV 1 to that, okay? So pin, let's do a simpler one to find. Okay. Okay. Pin 12. Pin 12 is right under PV5. So it's PV4. So find PV4. PV4.
We say on the board.
On your board, on this board right here. On your, if you've already normal Arduino, it's pin 12. Right? So on these boards, it's PV4.
It's so tiny.
Yeah. Also note how the lines on the label is out of diagonal, okay?
Oh,
So make sure it's on the right pin, okay?
Okay, wait.
So PV4,
Bond left.
No, I don't think.
Bond left side up.
so AREF is gonna be your topmost pin. These are location finders. Yeah.
Can I have something on my side?
So, you're not gonna bring it
Dude, that's he was like, oh, you guys have a learning to part. It was, we were like, oh, you guys have cardboard pieces.
So it should be the fourth pin on the top.
Dude,
Fourth pin from top, okay?
Fourth pin of it.
The fourth pin.
you just have 10%.
Like this TV.
The final 30%. The final 40%.
Bro, our file was like 45.
Yeah. We look at the diagonal line. Okay. And then your other pin, we're gonna, so that's your negative side. We're gonna put it to ground. So ground is GND. So find a GND. So there's 2 of them on your left side and 1 of them on the right side.
So it's gonna be on the third thing.
On the fourth, or the second pin from the
The
top.
second.
Second from the top. So I think it's the second pin from the top. Okay. I should have used the one that I'm actually using for demonstration purposes. All right. So I'm gonna put on my actual Arduino.
Yeah, Yeah, let me just. I get to check doing this. Can I get a picture of like whatever it is you're doing?
Yeah. Let me just plug this back in real quick and you can get it. So this is hid 1, 2, 3, 4. Actually, I figured I messed up. Okay, cool. Area's up here. Hold up. It's a little hard to see. Okay, 2, 4, 6. So it's 4 from the top. 6 from the top. 1, 2, 3, 6. 6. 4. Okay, and then this one here is ground. So it's up here. Right, okay. Okay. Are we all at the step? You want me to show how it's pinned out on my? Okay, I'll show that one.
You can pass it around.
I can't pass it when it's plugged in.
Oh, take a picture of it.
Yeah, I'll do it right now. So I'm gonna place it right over here.
So smart.
Yeah. All right, guys.
Alright.
Let's see. We're gonna. All right. Okay. Yep, it's a pizza buzzer. Wow, it's broken.
Like 5 volts.
5 volts. I think 6. I think it's a 6 volts. I think. All right.
Are you able to eat?
Yeah.
All right. Oh.
Yeah.
They're gonna be like,
Okay. I'm gonna put it right there.
just go home.
And then zoom.
Wait, my mom, I'm not on there.
Zoom.
Freeway.
Oh, yeah.
Oh.
How do I full screen the flap share? Okay. All right. Here you go. Oh, that's the wrong side.
Oh my gosh. Wowie.
How fancy.
Oops.
This
Alright.
is space engineering.
There we go.
Wow.
Wow. Oh, okay.
That's impressive.
That's very okay. There we go.
Wait, I can't see anything.
Don't worry about it. Wait, give me a second. All right, there we go. That way it's a bit more easier. Yes, see it better. There we go.
The real-time lag.
Yeah. Okay.
What am I seeing?
What are you seeing?
There's-
It's very simple right now. Okay. So
Wow, yes.
your positive lead goes into the second, the 12th pin. So it should be the. All right. Good or no? Yeah.
Oh.
I'll show you on the thing. Okay. I guys to see on this side right here. All right. Where is it? Yeah, find it. I'll show you on this side. Looking at.
So this is second report.
Yeah. This is nice and blurry. Okay, cool. This is great. Well, that's fine. Okay. Well, that's okay. So here's look on this side right here, right? There's on the top pin, there's a little diagonal line on the label. So make sure you line up that label. That label's on the closer down, but that's your diagonal upwards. Okay. Yes or no? Did you catch it? All right. Who's the color?
Okay.
Okay. Okay.
Yeah. And then you go in front. Huh? No. You know how like 2 USB like this now it's like the USB.
That's so complicated.
Yeah.
Oh,
But back looks they like just come.
I love MacBooks, haha.
oh, you can
Oh.
Yeah, but you back
Oh, this is possible.
I mean, my Windows laptop, I do.
You what?
I do work. So bad. Like I just back for that, and I just found some comfortable. I guess YouTube was. But I'm gonna die.
Wait, you're looking for the Yeah, I want to go watch. Wait, what is it called? What's it called? Wait. Wait, so I'm sure like. Wait, what time?
That's the afternoon when I saw separate eight. I want to watch that. You know, the parents, my kids, you know,
Childhood.
no, here's the thing, my kids get with that, my parents like, oh, we just go to the right after.
And we need help still or
Or
no?
no, take the bird or text it.
All right, okay. Let's go back to this real quick. All right. I hope I wanted I too. Okay.
I mean, I got it.
All right. So I'm gonna increase this blinking back to let's do 500 for now, okay? But we're gonna define a new function, new pin. Let's call it buzz pin or buzz, okay? So hashtag define buzz at pin 12. So I'm still using the Arduino pinout because this will use the space pinout. It's a different name on the actual report itself. All right. And then we're gonna do, let's call it note, okay? Const int note. Okay,
Do you have to have the semicolon specific down on?
so not that one, sorry.
Oh.
That was my my habit right there.
Can you do?
No, it will error out.
Oh, good.
So if you look over here, not here yet. Not that one either. Let's see, there we go. The frequency of at the C major, oops, okay, is 523 hertz, right? That's the frequency of the C note. So we're gonna do that. We're gonna get that note, okay? Huh? Okay. All right. Yeah.
I know we're doing it using double, but do they have any equivalent float or is it the same thing?
Float. They also have float. They have float. They have short. They have long. And everything. It's C language itself.
Okay.
I took 2 years of.
right.
So I'm looking.
But we're gonna do an integer here. All right. We're gonna put 523 as our current frequency. I'll even put semicolon here or I'm gonna comment here. Say this is gonna be the C note. All right.
Where's Papa G?
And we're gonna pin mode this pin 12. So pin mode buzz. And then do it output. Yeah. So what we can do here is let's remember this quickly. Is that tone? Oops. All right. Can we zoom bigger?
Yeah.
Okay. And then better? Like bigger. All right, yeah. Yeah, so
You're blocking. You just like tap one.
okay. So the tone function uses PWM pin to basically make a certain frequency out, right? So we want the tone to be on the buzz pin. So let's see. We'll do buzz and then put note. So you guys can see on IDE 2.0 and above, you can see like the actual constructor or the parameters it takes in. All right. And then we gotta do how long. Okay. And then when it on here, we'll put no tone. Believe. Was it no? There was okay, yeah. And then the buzz pin. Buzz, okay. So what this does, it will play a note at the note variable, that frequency on the buzz pin, and then it'll delay. So we'll put a note for as long as the light's on, and then it'll stop playing it when lights off. Okay. So let's run this.
So
Wow, we,
for that time, I'm not gonna.
Yash.
Okay. Well, for 500, I put 500 for duration. All right. Let's see. Can't open the serial. 46. That's the wrong to me. Okay. Let's see. Is it
Sounds like a fire alarm.
done? Now we're gonna get everyone's key part on my door. Yeah. That's your code.
How do we?
Can you?
Wanna kill it?
Yeah.
All right, we should. You should annoying. Okay, this do is just go over here. Oh, not here. Go over here.
Ah.
Oh my god. Okay, go over here. You give us control slash,
Oh, okay.
and then you can just run it again. At least it works. So that way people can figure out whether it's working or not.
Yash, can you help?
Yeah?
Can you
Yeah.
help?
Okay.
Yeah.
Yeah.
Bring your.
I think I wired it off. It heats up.
Yeah.
Okay.
Oh, yeah.
Yeah.
Um,
Can you just take mine as well? Give me them gloves. Alright. If I run this.
I'm making finance in terms of code. What? Then calculate PC, let me see how bad the.
Yeah, this is done. This is done.
Honestly,
Doesn't
yeah,
work.
fucking-
Or did I put it wrong? No, it's done. It's thank you. Mhm. So I'm popping this one.
Oh, that's not.
You're like, oh, that's bad. Oh,
What? Area. Washington, this.
You learned these values for later.
I'm gonna
That was fun. That.
Is this how loud yours was?
Wait, but can't you in the past, yeah? Finance.
That's loud. I mean, just make sure.
Second
I
place
heard loud.
down raw.
Okay.
It goes.
After you told us, like. It's like,
Oh.
you didn't give up. But you took the other passages, I get this. Now, pass rate 98%. Because your exams is so hard. The other exam is for something was BC level. Like during this, I think it's easy, right? Yeah, no, you took a BC during this and you do it.
I think I would say, I'm gonna stick on that.
Yeah, you know, I mean, for the second mention, when it goes on Saturday.
What?
8 AM was the ride. If you don't ride, if you ride later to 8 AM, you get, you're not allowed.
Yeah.
You get,
I think that's what I was.
you think where you, it's like, it's like, you go,
I would not wanna come.
Okay. Anyone else need help?
they give you the cake or one look.
Oh,
Okay.
Make sure you look at
Alright. Anyone else need help? Need help?
That's good. Physical health and safety.
Yeah. That's the drink.
No, it's.
Oh my god. Or just copy it.
Okay.
So.
Okay. Okay, 1, 2, 3, 4 people. Okay. E4, okay, you two come here. Sit right up here.
Oh.
Well, all you guys follow together.
Oh.
I special, high school.
Hold on, this is part doesn't have errors. Okay. There's no running or no?
Oh, yeah, I got mine. It
How'd you get yours to run?
was wrong board. It was, it's, no, it's,
What happened?
what is it? It's right here and you go to border and one way that you're like, eight,
Oh.
or I. Or sorry, there gives me two options. I downloaded this one for when I was. It needed down.
Oh, I did download that. I asked me, the system asked me to pay for it. I am working. No, you didn't know, so you can try working.
Oh, yeah.
But I downloaded it. So if I wanna do more stuff like this, are you gonna buy this to have access?
Well, I mean, you could, or, yeah, it's $15.
See?
The chip,
The
yeah.
board?
Yeah.
Yeah. But it tells you what I can do. What we can do. No.
Huh.
Oh,
Definitely.
Okay, cool, guys. You fixed it, you fixed it. Okay. I think you're
Bro.
One more time. Oh yeah, how I haven't thought. I mean, I don't see that you use it with this, but I didn't know how to now. I saw an application and I came with it. Like, do you have anything? I'm so big guy for this show. But it's complicated, or I haven't like looked into it too much. Oh yeah.
All right. Hey, what was that?
So this is what I see. Right, this one. I didn't touch
Oh my God.
Dad, what people can exchange it?
Oh.
93.
So you can do is,
93, not.
wait, so the frequencies you can listen to go from about 20 hertz to 20 kilohertz.
Oh, okay.
That's your audible frequency range. So you can try the entire range you want to.
Oh, okay. Let's take.
So don't pierce your ears though, please.
Oh. So because about your free out the fight every.
No,
You did, okay.
no.
Oh, okay.
No,
No, I'll do it for you. Just tell me where to go.
I told you what to do.
Huh? I just thought already.
But I can't.
Yeah, you don't change the
You may not. Can you?
Yeah, there you go. I'm not there.
Really?
Yeah, maybe, all right.
I've given.
I don't know that.
Yeah.
Oh my God. What have I done now? Yeah.
Wow. So, pero, you dijo 20,000 or 2,000?
20,000.
20,000? Actually, if I put like so higher, it's too much. The higher, the lower it is. I really want to like more than 1,000 vectors. Yeah, that's
So you do like 40%. Should be the same time.
Are we all having fun already?
Yes.
Yeah.
Okay, that's fun. Let's see.
No, the higher is somewhat bigger.
Yeah, I don't want to go too high. I have my percent years.
I
Yeah.
think 2,000. That was
Oh,
fine.
I'm just curious, but I have your report. By doing
So my board is actually, has two more pins, better pins on there.
Oh, that's.
I have these two as well.
Oh, that's fine.
Yeah.
Okay. So for those who didn't experiment with for loops yet, let's do for loops. So we'll basically increment the tone's pitch, up and then down.
Okay.
So linear, right? So what will happen is we'll see is the frequency go linearly up and then we know the sensible like one as well. So let's do this one. All right, guys. Let's turn off all the tones now. Stop it. Okay, cool. So much background noise now. Okay,
Oh my god, my is not.
just unplug. Okay, so let's do this instead. Okay. So let's set our tone to be 0 from the very start. Right? Nothing. And let's sweep through all the frequencies we can go and come back. And hopefully no one gets annoyed. Huh? 3,000?
Yeah.
No, like 20,000. Well, yeah. So what you'll see is as it gets higher into 3,000, let's say,
Yeah.
that's probably the resonant frequency of the speaker itself. So basically, the speaker itself, the atoms vibrate at that frequency, right? So if you vibrate at that same frequency, it's gonna vibrate louder because it's the same frequency is gonna superpose, and you get a larger like wave. Yeah, that's how you can break glass, or opera singers can break glass. If they hit the frequency of glass will vibrate so like a higher amplitude, it'll shatter. That's how like I have little plastic cups at home, and sometimes if I put a speaker for the same frequency or on the same frequency, they start moving away from me. So yeah, so let's do that, okay? So right here, let's delete all this code that we worked so hard on, right? If you guys want to keep the code, you can just do this, right? Keep it, just highlight everything, and then control slash. So it'll comment all in a single line comments. So so it'll be a lot faster to do that, okay? Control slash.
Oh.
All right, and then control slash again will undo that. Yeah. All right. So right here, Okay. So down here. Okay. Let's do a for loop. All right. For so int I equals 0, which means that I'm going to create a local variable or a variable that only exists within the for loop, right? So I are incrementing loop or incrementing, what's it called? A variable. There you go. All right, semicolon. This is the first statement. Next statement being I is less than or equal to our highest audible frequency you can ever imagine, 20,000 kilohertz or hertz. So 1, 2, 3, 20,000. 20,000 hertz. Semicolon. All right. So here we can do I plus plus, which means that we're gonna increment by 1.
No.
We can also do I don't know if Arduino likes that. I do remember it not liking that. We can try it, but probably other route. I plus equals, let's say 10, will increment by 10 in most languages, by the way. Arduino might not like that. Because sometimes I think, if I remember correctly, it didn't like that. But we can put it here. But I'm gonna put it as I plus plus for now, just to go through the entire range, okay? I also want to show you guys how it looks. So what I'm gonna do is, you guys wanna follow along too, you guys can do it too. Up here in the setup, I'm gonna do a serial dot begin, okay?
Oh.
Let's spell it right. So what this does is opens the console. So you know C out from C plus or C, that's what this is, the console. You're debugging basically whatever variables you want to see, like they want to read a value, right? Want to see what it actually is. You can use the console, and then we'll kind of show you on the bottom what's currently reading or whatever it's doing. All right. So with this, I'm actually going to do over here. Okay, let's first go here. Do open curly brace and enter. It'll also close the curly brace too.
Wow.
All right. So in here, we're going to do tone. And then we'll say our buzz pin, right? Buzz. And then we're going to put as I. I is our frequency, right? But I also want to do, we're going to do serial.print ln, right? So ln means line break. So what it'll do is it'll print out a value, the line break at the end, it'll bring my value down. So it'll be easier to see, right? And I put I as well. And then we're going to delay with the time, right? What is bro doing over there? Okay. I'm not done yet, guys. Come on. All right. So, all right. So we're going to put the delay as 250. All right. And then when it finishes its thing, we're going to put no tone. That way, we don't ever hear it again. No tone. And we're going to put buzz. And then actually, we'll still hear it because it's a loop, right? So we'll come back to it. So what let's do is, after we're going to put a while 1. Okay. And then what will happen here is it will be stuck in this loop forever and ever, and nothing will happen. It won't do anything else. All right. So please put this in there. I really don't want to hear it just constantly going up and down. If you guys want to actually want to see that, let's do that actually.
Let's see while
Yeah, basically while it's true. So it'll constantly be not doing nothing. It'll be stuck in that while loop forever and ever and ever. But what we can do is after this, so after it hits the top one, right? We can do another for loop. Right? So we can do another for loop. Int I is equal to 20,000. 1, 2, 3, right? That's 20,000. 20,000. I is greater than or equal to 0. Right? I minus. So that will go decrease by 1 every time. So we'll go from 0 to all the way up and all the way up to 0. All right.
for that while function that you put in.
Yeah.
So like once it completes those two things.
It'll never run them again. Yeah. It's great. But you see, I'm gonna copy and paste this right here. Come on, guys. Okay. So That is that. Okay, cool. And then we'll also put a delay over here for the same amount. So you see how it cuts off there? Okay, anyway. So I'm gonna put mine back on this one. Mine currently is on the old one right now.
Is that greater than?
Yeah. All right. So mine's currently beeping by itself.
No.
So let me first do it myself. Okay.
Okay.
Yeah. Okay. Is this everyone? All up? Okay. Okay. All right, I'm gonna run this code here. And we're gonna see a problem right here. I'll put in the while loop instead of the where should I put it? Okay, cool. I didn't put a for loop. Yeah, I forgot to put it over there. Okay. All right. Something I want to show you guys, but you guys have it all on. Oh my god. I know, I just myself, but okay. But one thing I want to show you guys first of all, right? Wait, guys, quiet down for a second. Your thing. I want you to hear this for a second. Right? So you see how it's kind of up and down, right? You can also look over here, the plotter, and that will show you the current what it's doing. These are all the values it's reading right now. And it's going up the frequency. It'll kind of plot the so as I'm increasing by 1, you'll see it's a straight line going up, right? And let's see. We're hitting 70, 80. Oh, it's too slow.
Wow.
Go faster, huh? Oh my god.
We're gonna wait here for like.
We're gonna here for a while. Okay, we're gonna go slower. We're gonna go okay. We'll go and put it as like no, there's nothing in the while loop. Huh? Yeah. All right. There we go. So you see it's ramping up pretty fast, right? And then when yeah.
We're out of here.
We're hitting these at the very top, 1000 something. So we're gonna hit all the frequencies, but really I'm gonna stop it. So we're hitting pretty annoying frequencies. I'm just gonna unplug this real quick. Right? So I'm gonna go back to let's say leave it at let's say we can make the max frequency, let's say, let's do that right now actually. Let's do int max or constant, right? Const int max. Oops, I spelled that wrong. Const int max f for a frequency. Let's set it as, let's say, honestly, 1000 was enough for me. I don't know about you guys, but that was pretty enough, right? So we can go right here, put say max f, and then max f, right? All right, there we go. So now, I'm pretty sure this is right now. Let's see, what's that? Okay, currently we're hitting 7,000 or so. I don't think I want to witness that. So I will try to like send this real quick. Okay.
What's the max step is just another one that's kind of limited by.
Yeah. So if you see now, so when it hits 1000, you'll see it go back down the same slope. So as time increases, this increases about hit 1000 and it should we go back down. Right? And then it'll 0. And there we go. And it's okay 0, right? So if you guys want to make it into a sinusoidal wave, right? So let's go back over here. And let's go instead of I++, let's see. We're going to say a sine wave. So let's say I plus equals sine of what angle? I moves I. Okay, we'll do a simple one for now. We'll do I plus equals I squared. All right. Let's see what happens here. We'll run it. Hope it does. And that's the same here. 10 plus equals x squared. Yeah. Huh? Ah, good catch. That would be unfortunate if I didn't. All right, let's run this. My error. Oh, okay, it's cool. All right, let's see this one now. So we'll stay at 10. And all right. Why is it equal to 10? Also, with the serial monitor, you can go click on this button right here. You can see its current output right now. So it's outputting 2.
So why do you change?
So why does after pressing serial, after opening the serial, right? So up here is your still plotter. Your plotter is gonna be this graph right here. And then up right here is your monitor. So your actual values that are reading. You can do that. So you can have fun with that one.
Okay, so
Yeah, guys.
Yeah, so that's gonna be your concept.
So I minus equal.
So don't put that one.
No?
No.
Okay.
But I was thinking test to see if it was gonna happen, but it did not. Let's do I minus minus. All right. While for int I while I less than that one.
My computer's a little.
We don't want that.
No, my.
No, as in, she can't charge her computer at all, like it doesn't let her charge.
Yeah.
Exactly.
It's not eight.
Oh, yeah. No.
Oh.
Can you would hopefully then.
And you know what? These files are right here.
I get a hard drive and print another one.
Oh, okay. No, but you know, these files goes by the, okay, did you take the hard drive, did you get the config over that?
Oh yeah, yeah. Oh, but they're like the files themselves can do that, like download PCs again, I guess.
Yeah, because you need to get information on the PC where you can install it.
Yeah. Yeah, think that. All right, let's go back to I++ for now then. I plus equals 2. So if I was going about 10, you can go I plus equals 10 and it should work. And same with everything else. All right, let's do something else. Okay. Yeah, it's okay. It's like a function.
Well, my thing is telling me that it's staying in the same thing the whole time.
Yeah, you do I square, that's fine.
But
So it goes so fast up and then go back to 0 and I'll go the other way. That's fine. Is that from this one?
Alright. Yeah. Thanks.
You get soft skills basically.
Here, right, that's where your daughter.
Yeah, so ponder over those graphs. All right. We also have a button, right? Remember the button, small button. So, is there a extra marker? All right. All right, first button. You guys see where the leaves are? The leaves are to be coming out from one side, right? There's an orientation.
Oh, I got it.
Those are the hooks are, right? I is very important because it all determines how this is actually wired together, okay? So make sure, say right now, make sure these are pointing up. They're coming out from the top, from one bottom, right? So your left leaves are all put together. Your right leaves are all put together, right? So if you put something in the bottom, yeah. So if you reach, let's say, a signal to the bottom left corner or the bottom left lead, your top left lead will also have the same signal because it's the same line. But if you press the button down and you click it, And the other two leads to the right leads will also have the same signal as well. Does that make sense? No?
No.
No? You have the hexagon marker?
You don't know?
Yeah.
Yeah, I do.
I'm gonna mark it on the board. All right. What I need is you have these things like this, right? You have these like right here coming out of this, yeah. So inside the switch is actually like this,
Oh.
right? So if you put it in this way, it will go straight out this way. But your button is right here. So you press it and these two will also turn. Also take a signal. Okay? So basically you're saying is if you are taking the side, if you are let's say the signal higher on the side, you're gonna always get the same signal.
Right.
You never will come to this at all.
So you put it in the other
Yeah, always got the opposite side, opposite.
You know, okay.
Same.
Okay.
So
Oh, wait, you know what I'm gonna say?
I guess.
So while you.
Okay, on your board. We had a buzzer on here. I think I'm not. Okay, but basically, you want to put it across the center again like this. Yeah, in the middle. All right. No, you can leave it on. Okay. But we're not doing like this. Okay. Put it on your board across the center.
So this, okay, it looks the same if I put it like this.
So your legs. See how the legs are coming up? They're not coming up.
Okay.
So your legs have to be.
If inside, like both inside like that?
Yeah. So not grip with corner.
Okay.
Right? So make sure your the leg now they stick out this way. Okay? Right? So like one of your bedboards should be on like that side. Okay? Yep, exactly. So anyone not understand? We're all here? All right. All right.
Yeah.
All right. I'm going to share my screen. Okay.
Yeah.
All right. I'm gonna do it up here. Okay. So we have a buzzer on this corner for now. Okay. What I'm gonna do is, how many wires does everyone have? 5?
I have another, I have 3.
All right. More ground. Okay. So we'll do. Use your grounding wire, right? Find your ground pins. And point the minus of your breadboard. So let's see. There we go. So that's where your ground. That way your entire ground line of ground, yeah. So you can use this now to basically ground the button right here. And then we're going to okay. And then you can put your positive wire back on your buzzer back into your buzzing pin. It's not plugged in. All right. Okay. And then for your button, for the ground, On the other side, we're gonna put into a random pin, let's say PD7. PD7 should be pretty simple. It's right there. It's not diagonal on that one, so it's right across.
Which one is it?
PD7. PD7 is
What would it be?
pin 7, I believe, actually. Yeah, it's pin 7. All right. Does anyone need any help?
Okay, ground to ground, power. PV4 is positive, or positive. Okay,
This is not PD7.
You can put the ground bar on the
Pero, parecen la same thing.
No, it's on the different pin. If we look at the
What pin did you use for the input?
I use PD7. PD7. So I was
Negative. But, okay, this is two like this.
yeah, so these two are not the same. These two.
Then, I'm like,
Did you move this over to negative?
I may have forgotten to put a negative wire on the filter. Yeah, the buzzer is also the negative wire.
Wait, bus should negative wire, but shouldn't this be like positive?
No, that's
No?
because of the negative bus.
Okay, so that's just scrap.
Yeah, that's I just want to put another wire for the buzzer itself. There we go.
You can't just connect this directly there?
'Cause I want the whole bus to be.
Okay.
Yeah, mine's annoying, so I'm going to come back to this. Share screen. Okay. All right, let me quickly just do this. All right.
También, ¿por qué hay como todos? Pues que.
All right.
Pero cuando cargas.
Okay.
Sí, es.
Ya. No, you do this. Mine will be like that.
Okay.
Application I got for. But this is the example of these.
You don't have.
Or is this guy?
Oh.
I don't have like that, like. Yeah, no. Or like. Yeah, it's this guy. Yeah. Well, yeah, but I did not use it. It's the board, yeah. But either way, this was the law. Like I did, I just Dave, like this is an example. It's one if I click use word, it's a touch button. So we need more Wi-Fi. Like this one probably if I click the line, the LED.
Oh.
I mean, this, it looks like, but,
Yeah.
well, it's things like, what, like, I or get like. I mean, it's fine, that's fine, but as in, it had all these files, because, probably because as in, you have to have all the files. But like, as in, I don't know, like, as in, yeah. Like it said, yeah, but I don't know how to. Mess around to like. Because to explain what computer.
Okay. Are we ready? All right. So what we're gonna do now is a very simple reading, okay? You press the button, our light is turn on. All right. So let's go back up here. I just comment everything out for now, but you also delete everything later. So I'll leave pencil 13, but we're gonna do another one for a button, right? So let's define a new button pin. So define. We want to call it button. I'm gonna pin it as 7, pin 7. Okay.
No, yeah.
No.
That's not cool.
Right. I keep forgetting. Sorry. Okay. Right here. Let's do. What do we do here? What do we do up here? Pin mode. Okay. It's the pin mode. Huh?
We have to like make a variable and assign it to value.
Yeah. So for the button and 7 for now.
Okay.
All right. So pin mode. We're gonna do button. All right. Is it input, right? Is it input? All right. Before I continue this though, let's press semicolon. All right. Let's go back. At the moment right now, look at the way that we wired everything up. Our button is gonna be sensing ground, right? So we can't use this as input, but it's input pull up, right? So we're gonna put, underscore pull
Oh, but
up.
inside of my.
Yes, that's inside the predicate. Oops, I'm sorry. I cannot see that.
You mean it's gonna be sensing ground?
Huh?
You mean it's gonna be sensing ground?
So the way that we wired it up right now, we have the button on the ground line. So when we press the button, the ground will be the one that goes through the signal line. You guys.
Oh, I see. Yeah.
Yeah.
Okay.
So I'll be sensing ground. So if you had normal input, it's already at 0. And then if we're not gonna put any 5 volts into it, we're gonna put 0 into it anyway. So it won't let me detect the actual button itself. Because whenever you press it, it's always gonna be 0. Sorry. So pulling it up, its default value is now 5 volts, and it's gonna go to ground every time we press the button. That good? All right. So let's go down here. Let's let's go up here real quick and make a variable right here. Say int, we're gonna call it val b for button, okay? And we're gonna put semicolon right there. So over here, we're gonna do is val b. So we want to put this as we're gonna assign this variable the value of the button, signal. Does anyone know which function that is? Not while. No, huh? Huh? Read? What kind of read? Digital. Yes. So let's do that. Digital read. Yeah, this is in the loop. Make sure all your main functions for sensing data is going to be in your loop function, okay?
The declaration is that.
Yeah, that was right outside of it. That's just how I did it because I don't want to keep declaring the same variable over and over again. So I'll do it once. So you can also put this variable up up top for the setup as well. I tend to make my variable before the loop or when I'm doing the loop function, like when I'm doing the main functions as well. All right, so read. I'm gonna put button and semicolon. All right. And then we can do serial.println. the value of button. So that's gonna be val B. So you can see what its current value is. So just leaving it as like this, let's run the code real quick. So what will happen is, oops. All right, let's look through our monitor. It's right now 1, right? I press the button, it's 0. 1, 2, 3. So this is a pull-up. So normal function of input, it'll be 0 right now. And if I put a 5-volt in, then it'll say 1. So okay. So let's line this up with our LED, right? So if our button is pressed, we want to turn the LED on. What kind of statements do you want to use for this? If statements? Yes. So if, now since the val B, right, is going to be 0 or a 1, that's basically off or on, or false and true. So we're going to just do if val B. That's all we need to do, because it's going to be 0 or a 1, false or true, right? So if the button is pressed, we're going to write, so how do we write the LED to be on? Yeah. So digital, oops, I spelled it completely wrong. So write LED pin high. And then else digital write LED pin low. And we do this. So right now, if you see the LED is on, I'm not pressing the button though. When I press it though, it's off. It's the opposite. So how do we correct this? We can do that where we can manually put low and high, right? Or we can use the not operator, right? If you use a not operator on this, just doing it once. Oops, not here, not there, right there, right? Just doing it once over there, two different values, right? Just adding an exclamation point. That will inverse the actual signal, and now our LED is off until I press the button and it's on. Right? So, is it working for everyone? Are we going too fast?
No, it's fine. Yeah, I wasn't used to the changing it.
Yeah. So
Yeah.
sometimes figure out, yeah. Yep.
So, you want to try it? It just makes it easy where you are, how far you are. Look at it
Okay, we're all good? All turning on?
I'm not a person who's
$7,000.
One of your English and navigation as well. Yeah. I think I'm doing this. Really bad. Yeah, you don't change the.
As in, you just put turn on. Uploading, I guess.
That was my, I was on like, Reddit post, like inspection video, someone was like, I'm thinking about somewhere saying so far, like, you have done major. Like, the email part is really easy. The graph part is really easy. Like, they kind of start, how we,
Okay. Now, what we'll do is, let's see. Logic, yeah, that. Serial. So I guess I know how to like press the button and then make lights go up as well as the buzzer. Do you guys want to do anything with it?
Can we do sound and like, can we put the sound in the button?
Yeah. You click it, you can also increment the, if you want to do say, increment the tone every time you press the button. They'll do that too.
So if I put it back to like how we had the sound, can I just connect like in midway?
No, you have to build it as well.
Alright.
I mean, you can hard do it where like basically you put it in the series with the buzzer. So that when only when you press the button, when they'll let the current flow, then they'll actually increment one wrong. But if you want to do, let's say, if you want to do increment the actual tone of it, then you can do that. But that'd be like recoding.
No, like everyone can do it.
Okay. Once again, just in case for those who didn't catch the breadboarding part. So. Again. Okay. So. Let's start us all again, I guess. Okay. So. We have these two as of right now, right? Is that good? And we have the button so that the leads are, you can see the leads on this right here and down here. Okay, so real good that way. Okay. What we're supposed to do is find the ground. The ground pin right here is ground right here. And it's gonna find the ground over here. Okay. For me, it's the fourth one from the top. For you guys, it's gonna be the second one from the top. Right? Your pin is the second one from the top. And we're gonna put it in the minus. Okay. And then we're gonna find PD7, which is the 7th pin from the bottom. And we're gonna put it right here on this pin right here, or the button. So the button can see that pin. That is not with that pin. Yeah. Next, we're gonna put the buzzer pin, which is pin PD4, which is just one away from the ground pin. And we're gonna do that on the bus. I'm just reading the same circuitry before we make that. All right. So that's gonna. Am I going too fast? Good. Okay. Next, we're gonna do is we're gonna ground the buzzer with the ground bus line and the ground of the buzzer. Okay. And last but not least, when I ground the actual button, you can either choose whether the leftmost, and mine is leftmost. Let's see if we can showcase this one there. Leftmost pin right here. Or we can go on along the bottom right here. So I'm gonna do this one right here for you. And you're gonna ground this one with the ground pin. Now we have that makes sense. We're all there.
What was the last one?
So I just grounded the button. So is that confusing? That's the confusing part. And now because the button, it blinks. That's that. There we go. Okay.
Like, you know,
I'll present for you. Give me your confidence. I do this.
Anyway.
Oh, no joke.
No. Okay. Okay, so we all did this. You don't do anything with it? You want to do like say a, I don't know, a button toggle? No, that's kind of hard. A little bit. We gotta be balanced stuff. Are they all good? They all have fun?
Oh, yeah.
Tired? Me too. Okay.
I think that one was all. I was focusing on it.
All right. Okay.
Oh, wait, is it?
Hmm?
Oh, it's just LED. No more buzzer?
You know the buzzer as well?
Oh, but your button doesn't LED.
Yeah, for not the LEDs, it's LED.
Okay.
All right, let's say
They're gonna be, they're all working on
The third one? No, we gotta go a little more advanced.
it. Yeah.
You guys, I one. You did next one.
You make it like a, it's like,
A little piano? Alright.
like a piano.
Okay, alright. You know, like the soldering workshop circuit? Like, I saw a little mini piano.
Oh, yeah.
So,
Like,
I'll get some, say, how many keys do we, you know, how it's- alright.
I think shoot, I'm working on it, but that's getting someone up. Or you know.
you think that I learned in math, it's so better.
The class, it's just in the class, you're talking about.
I think you can. Very like, very.
Oh, yeah, like, yeah. That's true.
I kind of. Yeah, but I have to do. The game, like, after. Basically, after. Maybe, and really, it's like inverted, and have, like, something, so nothing says, so it's a line card, I go to the top, units to make it.
My mom is still getting me when he comes.
Yeah.
Ah,
I think I
Yeah.
my plan for.
Say, say, oh,
But it's like,
you can do something. You can go clean up.
no, it's but the nature of things, it's a minor graduate.
but sometimes you turn it off or.
I know.
Oh.
I don't think it's so. I think and I clear it.
Alright. Yeah. What's your pen right now?
Yeah, sure.
Well, thank you.
Make a pen. No?
Do you think you can talk it with
You did. Hear it again. But Cody, get
Not with this.
Oh,
I can do it, but anyways, yeah. So I think it's.
Or I mean, Alright, I guess you follow your preference. Do I get the wire?
You didn't know why.
gotta run.
I don't think.
Oh.
Ah.
I think.
Well, yeah, I'm gonna wait for
There's.
Yeah.
Interesting, or, and this one, we're gonna be learning big on you.
I mean, it is a cool thing, right?
Yeah, after every $25.
It's. Oh.
Yes.
Stimulating.
So that's five.
You're gonna hire, yes, it is, yeah, you're gonna,
But no, you know, we have no.
yeah. It would be like same place, yeah, like, should have already have the buttons, stuff we need, you don't have to do.
Okay.
It would have to be this, like, you would have. Lines, all right? You just have Oh, I thought you were talking about. Oh, yeah, and then, yeah, you use the buzzer, you would wire. Okay. It's similar looking to the.
Which one brings?
No, I Guys, it's almost.
Actually, got that.
Now that you wanna keep everyone to cut it, then we have time to already get the budget. We just quickly cut it and it's just wire it.
Alright.
Oh, this.
Okay. Let's code this. Alright.
And.
Alright.
Alright.
Alright. Okay. Button. Alright. Button A. B, C, D, E. Oh no. 7. Oh. 7. 9. 10. All right. Oh, no. Oh my god, no.
I think they're pretty actually.
Oh, I didn't.
I'm joking. I didn't.
All right. Okay.
Yeah.
Well, really, it's not like or your cable, there's gotta be something with
I think, yeah, also this is your Arduino, right?
yeah.
I mean, maybe after the workshop, I'll
Sure.
try to do it. I guess I'll see about the. Oh, yeah.
I can probably just Google it and do it.
Thing, it's been a long time.
It's like a.
Let's get a lot. Like, let's just get it down. Like, see. Now, yeah. Why is this one? Oh, period. Oh, okay. I can't see. Oh, there you go. All right. Let's see. All right.
No, I was saying.
See. All right. Right. So after this, we gotta do an if. Oh, okay. Switch cases. I know it's so bunch of if statements. No. All right, here we go, guys. Actually, That's a good time to do this. Let's see. Oh, okay, I do this, okay? We can do void. Let's make a function. Let's call it play tone. Right? In play tone, we're gonna have two variables. We're gonna let's see, our int or val, and then we're gonna have for a bus pin, we have a val under val AB2. And then okay. Let's say we do tone buzz. Oh, it felt A. Right. So if that first one is pressed, then play it. There was no point for this function. There was no point for this function that I made. Kind of thing. What would be the most? That's the biggest way to make this work.
It's just to have one tone.
Yeah. No. Based on different like, I can do a simple example.
You know.
You know, we can make some switch, yeah.
But it's not for the valve itself. But you can say it'll be. You know what you can do is use a switch for the count. So you can do instead of this actually. Okay.
Oh, yeah.
So we can do is say, if say not val A, then want to play the C notes, right? So note. No, flow last time. Okay. Let's make another function. Let's make another so cost int notes. So let's say we'll put C note. Or note C. Note C. Not C. Note C. Right. And that's gonna be at 523. All right. And then we also have so D, E, F, G, H.
I have a website called.
Okay. As C, the note D is equal to note C times 9/8. Says C D E. So C D E S G. C D C D E F D. C D E. Alright, so note E.
Like all the values right here.
Ah, fun. That's easier than
Yeah.
Well, yeah, exactly. So you said C is 520, so with C sharp would be that. Yeah.
First of all, the D and
D is 587.
oh, okay. Let's do that then. No C. That's 587. No E is what?
E 329.
No, it's 6.
Oh, sorry, 650.
659. Okay. Then note
F
F
is 698.
698.
Yeah.
Note A. Oh, G.
G 783.
What? What?
783.
So that's 74. Okay. Note A.
A 88.
80.
B is 987.
And B. 987. Okay, cool. That was a long time. Okay, cool. Cool. So if not that. All right. If not that, I can't even see this with properly. This is sequence. Okay. So tone. So oh, we're gonna get another one here. We're gonna call it int. Int play. Right. So
I think it's okay.
play with notes. B. If I'll be here's the I'll be probably
Oh.
Oh, yeah.
No, because I remember as we was the family were like big wallet, big that about me everybody.
Yeah, like what's one
all right. See, oops.
Yeah, I can see it.
Okay, thank you. If I went to wallet or down far, I'll be dead. I'll be dead.
CD.
I was like, why didn't you do this? You're people with that.
Bar sucks, right?
What? What? C, D, E, F, G. Ah, we don't even need A and B because we don't have those. Okay.
Like zero, no average. Like,
Huh?
it's like,
And I play both the.
it's good.
And then I'll meet you with
This is not that loop for you.
Oh, my.
Yeah, because
How long does it take? Or fast enough here.
Yeah. Oh, yeah.
play like basic planes.
Sure, take like.
Yeah.
Why? I like.
But there's like a goal line. I don't feel like I'm gonna split plays. So that like.
I'm recording on. Don't follow this though. I'm not gonna finish this code right now. So it's nothing a lot, but basically you have Canada and also don't have everything. You guys know how to do it. I'll do it at home and I'll do it. No, architecture policies are. But yeah, thanks for coming though, guys.
I should have put the visitor.
Yeah. Yes, you keep your argument. Yeah.
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 Let me stop recording this thing.